Hello, everyone. I am Peyman Daneshvar from Iran, and I am very happy that I have received another opportunity from the PEA Institute to present this course. And I hope you will enjoy this course and the presentation, and it will add to your knowledge even a little. Let me start our well stimulation webinar about acidizing. Let's start it with outlines. What I want to talk about basic definition about the well stimulation, formation, damage, acid type, so acid treatment type, and matrix acidizing, and also about the additive, a little about the acidizing procedure, overflush, preflushes, and also a laboratory test procedure. And also some slides with some stars that I want to talk about geothermal well acidizing. I think that is a gift to audience to maybe enjoy about this one. So what is the well stimulation? Well stimulation is a necessary intervention intended to enhance the permeability. If you see the chart, when we explore a well in an oil production, okay, we can see that a well increase the pressure. Okay, now we are in a build-up, and after that in a stable production. But after some years, or after maybe some months, or some days, the production will be decreased. Okay, now what we can do now? Here, the simulation engineer is like a doctor, should be uh, very very professional about the sickness of the well, should find the medicine for each well about each damages. So every time in my webinar and also in my workshop, uh, remind this formula. This is a mother formula that we every time come forward with this one. It is about the production rate. It depends on the permeability, thickness, pressure, also wellbore radius, a skin factor, and also a volume, and also a oil formation volume factor. So if you keep it in your mind, this formula, and after that, in the next slides, we see that in a table, why this formula is important for us. We have some simulation techniques, but just here, I want to talk about the matrix acidizing and some slides about the acid fracturing. Here, I don't want to talk about the proper hydraulic fracturing, because I think that last year I conducted 3 hours webinar for the hydraulic fracturing, and this is just for the acidizing. So our aim to, or our goal in a simulation is reducing a skin factor or a skin effect, reducing bottom hole, increasing the factor of the permeability or thickness, or decreasing the skin factor, or the ratio between the radius of penetration and available radius or viscosity. If you see here, for fracturing, our goal is the increasing the wellbore radius, and in matrix acidizing, our goal is the decreasing the skin factor. But in acid fracturing, we increase the increase the drainage area, about maybe drainage area of the wellbore radius, because we want to, with a leak of the acid, we want to increase the wormhole and bigger. So in a well simulation treatment, some parameters are important for us. we should consider about all of them, about the formation and mineral composition, about the what type of a damage and how and amount of the damage, about the contact time of the chemical that we want to do to cure the well, and also a limitation about the well equipment of in normal. Maybe we want to acidize in the well, but the coal cannot reach to the depths of the perforation, so we should bullhead it, because every time we should consider about all the stuff and everything that we want, about the bottom hole pressure, temperature, about the uh, compatibility of the additive, or also about the contaminating of the water, mud, cement filtrate, and also about the solubility, about the permeability, about the porosity, because we want to, if we want to design a plan, we should consider all parameters together and together. What is the formation damages? Formation damages is a thickness of the well is the formation damages. When our permeability reduced in our reservoir rock by invasion of drilling fluid or anything that damaged the well, we consider with occurrence is like as the formation damages. Sometimes we call that a skin damages. You can see in photos that about the skin damages in a sandstone. In a sandstone type formations, some element plug the sand, and we should find a best way to cure this well. We should simulate this well. You can see here our formation damage may occur in a drilling, completion, workover, kill jobs, production, and also a simulation when we don't find a good way or best way for the installation. If you see that invasion of the mud cake, invasion zone of the mud, you can see that this is a formation damage and will be decrease our permeability near the wellbore. We should clean it, and the formation damage can be from a little to 10 to some meters lying away formations. Here, some formation damages stop. Some formation damages are natural in a well, as like as a fine migration, swelling clays, organic deposit, or also we can category in a deposition, as like deposition, organic, or also emulsion or water form scale. And some damages are humanity, by human, we do it, as like as the when we do a simulation jobs, when we uh, wants to acid, and our acid volume is not okay, beside is not okay, and we damage our well, and it's not okay for us, okay? But you should know about that. This table is important for us because you should consider about all parameter, because you should know about that. Where is the scalas may occur? The scalas can be in a tubing, in a gravel pack, in a perforations, in a formations. This is a table that every simulation engineer should know about them, and also should know about them, that these damages will occur in a new well or old well or an injection well, or you should all times consider about all this category in this table, because you should know about that. You should know about that the all sickness of the well or illness of the well. Some slides in our webinar with some stars, because just I want to tell more something about. Sometimes somebody ask me that about what is the scale. If the attendants follow me in a LinkedIn, they saw that some posted about this parameter and also about some main object about the simulation. This is one of them. What is the deposition and what is the scale? You know, deposition deposition as like as a mineral, as like can be as like as a mineral, organic and mixed. But be careful and keep in your mind, a scale is a mineral subcategory of deposition. No difference. Scale is a mineral subcategory of deposition. Here you can see that some organic scale that very give us a headache about the asphaltene or paraffin. You should know about what is the difference between the asphaltene and paraffin and what is the medicine for the cure these diseases or illness. If you see that for the asphaltene, we can use the aromatic solvent such as a xylene or toluene, and absolutely, I think that maybe you can add some mutual solvent or some surfactant to this one. And when you comfort with the calcium carbonate, you can solve it with the HCl acid. When you silica scale, you can solve it with the hydrofluoric acid. And some scale that you can see in these slides, I think that you can take a picture or take a photo from these slides, some slides that you want uh, uh, to keep it your mind. So what is the scheme factor? You know, we talk about the formation damages, but for formation damages is a uh, you know, it is not a quantity that you can use it in a formula. You should define as a quantity as formation damages. You know, when you scheme factor is a dimensionless parameter that quantify the formation damages around the wellbore. So it can be negative, it can be positive, and also be zero. Okay, zero, no problem. But when we have in a negative form, it means that the well is in improvement. When is in a positive, so this well need to a simulation. You can see that the Hawkins formula, this is the important formula about the scheme factor. If you want, and I will talk about the scheme factor in my workshop. I think that maybe in November, we will talk more about the scheme factor of the perforations and also more and more and more. Here, sorry. You can find this formula about the vertical well and about the horizontal wells. You can see that when the scheme factor is the positive 10, okay, you can see that our production very low. But when our scheme factor about the -3, our scheme factor is more than the normal. Okay, if you can see the chart in the left side of the slide, you can see that when we do a simulation in a well, okay, our scheme factor, if our simulation jobs is good, okay, our scheme factor will be go to this minus side. But if we explore a well, okay, left it and we check, we don't think about that, and just we want to take money from that, it's not okay. After some days or some months or some years, it will be production will be decreased, and the skin factor it's show to us that will be a positive in a positive. You can see that again in a formula, just for the biggest slide. Sometimes in a formula, we should consider about the radius of damage. You know, when we want to use it in our formula, because the client maybe tell us about the 1 meter from the wellbore. Okay, 1 meter from the wellbore. What is your wellbore radius? When you want to use it, you should you should plus it with your wellbore radius, and after that you should use it in your formula. This is a normal, just for the recommendation. And the skin factor that every time a client give us, or the production engineer give it to us to give it to us, is a thought is a skin that about just we can do with a simulation job to decrease it. You know, we have some skin damages as like due to perforations, due to gravel packing, due to partial penetration effect, and also due to push the skin factor and rate dependent effect. Yeah, and because every time we have a skin in our completion, a skin in our gravel pack skin, so the skin is a total of the uh, formation damages and perforation and all parameters together. And how we can obtain the skin factor, total skin factor, just directly we can obtain it from the well test analysis. This is the example that take a picture. You can do it. Just think about this one and check it. This well need to simulate or no. What is the acidizing? The injection of the acid or pumping the acid into a well or into a formation, it means that the acidizing. Okay, this procedure enhance the production by increasing the effective wellbore radius. So just for the history, the first acidizing jobs with the Ohio Oil Company, with the man Herman Fresh, did it in 1895. And after that, you can see that this table, the improvement or development of the acidizing. And nowadays, we do acidizing jobs in a professional, with a diverter, with a coil tubing, with a professional equipment. I will tell you about absolutely. I will tell you about some new technology in acidizing, as the EHS tools or STMSTX tools. I think that in my last slides. What is the acidizing objective? Remove the near wellbore formation damages to decrease our skin factor. Remove the restore damaged matrix permeability in a sandstone formations. Improve matrix permeability in a carbonate formations, and maximize the well productivity. How? With decreasing the skin factor, with increasing the wellbore radius. And also removing deposits from the tabular or wellbore for clean out it. In acidizing, normally in a normally we have two type of the acid. One of them mineral and another one is organic. Mineral as like as the acid that we use it nowadays, HCl or hydrochloric, and HF or hydrofluoric acid. Hydrofluoric acid, good for sandstone formations, but when we want to do jobs in a sandstone formation, we should consider about the uh, volumetric so, mm, about the volumetric forget this name, sorry. Sorry. In a sandstone formations, we use the mixture of the HCl and HF as like we told that mud acid. But in a carbonate formation, we use a HCl acid. We can use the organic acid like as acetic or formic acid, but acetic acid and also a formic acid are a organic acid reacted slower than a mineral acid. Okay. For example, a formic acid we can use it as like as the additive in our acidizing. If somebody here, a chemistry engineer, should know that a formic acid can be used as a corrosion inhibitor intensifier, can help to our inhibitor, okay? And acetic acid, we can use it for the iron controller in our acid jobs. Please keep in your mind about the molecular weight of the HCl and also a HF acid. These are very important because we should know about the HCl reactions with the formations and what is the product of this reaction. For example, when the acid reacts with the calcium carbonate, our product will be a calcium chloride, carbon dioxide, and a water. So, and when the HCl acid react with the dolomite, we can see that the calcium chloride, magnesium chloride, carbon dioxide, and water. This is a question just for yourself. After acidizing, here I told that the CO2 is one of the product of these reactions. After acidizing, where is the CO2 going? Just think about it. If you know, please write it in your comment box, and I want to know about this knowledge. You can see that here, when our hydrochloric acid percent is about 15, our calcium carbonate dissolved per pound per gallons about 1.84, and these are the some details about the acidizing about the HCl acid. And for the HF acid also, it's important for us that a hydrofluoric acid with the calcium carbonate, it gives us a calcium bifluoride and carbon dioxide and also a water. Yes, let me, please, I think that maybe after 20 minutes more, I will give a 5-minute break time and you can ask your question. And after that, we continue our webinar, okay? When our hydrofluoric acid react with the sand, you can see that fluoxylic acid with the water. This step. Keep it in your mind and see the next slides about the reactions. For the acetic or the formic acid is also as like as the HCl, you can see that the calcium acetate, carbon dioxide, and water. You can see that the what is the acetic acid? I told that you can use it for the iron controller, and formic acid you can use it for in a corrosion inhibitor intensifier, and you can see that how much pounds per gallon can be products of the acetic acid with the calcium carbonate or also the formic acid. Here, just I want to know some when you want to find the specific gravity of the HCl acid in a field, you can use it with uh, in a field test. You can use it with two simple equipment: hydrometer for the for the find specific gravity, and also thermometer. You can find if you uh, look at the at the graph or in a table at the middle of this slide, when you correlate the specific gravity with the temperature, you can find it the percentage of the acid in a middle line in a middle slide. Okay, and you can uh, see that the important of the uh, acid specific gravity in this table. Just keep it your mind. For the 5%, 1.025, 10%, 1.05, 15, 1.075, and for 28, 1.141, and also for the 32, 1.163. I write a formula for the rule of thumb that if you don't know about the specific gravity, you can use this formula with this rule of thumb that 1 plus 2 number of percentages on the as in the denominator and divided on a 200, you can find the specific around almost a specific gravity of the HCl acid. What is a mud acid? I told before, the mixture of the HCl with HF is a mud acid. So we have two type of, we have more a type of the mud acid, okay? But two type of is a regular, two type of is common. One of the a regular mud acid, it has a 12% of the HCl and the 3% of HF, and another one, a super mud acid. It's a 12% of the HCl and 6% of HF. So keep, in a field nowadays, maybe in the past, they bring a HF in a liquid form, but nowadays we don't use HF acid in a liquid form, and we don't bring it in a liquid form for our in operation on a field. We mix the HCl with the ammonium bifluoride with the uh, uh, ammonium bifluoride powder. In our product will be have a hydrofluoric acid. You can see a table here for mud acid, that if you want which percent of the HCl and which percent of HF, you can use how much ammonium bifluoride. But absolutely for the regular mud acid, you should keep in your mind, you should use it a 400 pounds ammonium bifluoride in 1000 15% HCl, and for the super mud acid you should use 800 pounds of ammonium bifluoride in 1,000, 18% of HCl. And if you remember, I told that about the reaction of the HCl with H and also HF like a mud acid. You should keep it in your mind. You know, when in a first stage, when HF and HCl go inside the formations, okay, just it's just HF expanding, but the HCl will remain. And after that, in a next stage or in a secondary stage, the the remain HCl will react more, and in a third step, the remain of the HCl will be react with our element in our sandstone. Okay, you can see that in the first stage, our hydrofluoric spent, damage dissolved, okay, but HCl not spent. But in a secondary, our silicon and sodium polysilicate precipitation may occur, okay, if remained in our well. In a third one, our aluminum precipitation on our scaling will be occur more, okay? Just be careful about the reaction of the acid in our formations. Here is some formula that you should find it and you should know it about the gravimetric and volumetric dissolving power of the acid. Why? Because when you know about the reaction of the HCl or HF or acid with the formations, you can find, sorry, you can find the uh, stoichiometry number that is important for us for finding volumetric and dissolving power and gravimetric dissolving power. When we find these two items, we can find the volume of acid that we want to acidize the well. Okay, this formula in the left side is you can use it and you can use it in a for Sandstone acidizing. In our workshop, we will explain it more and more. And in carbonate acidizing, we should use this right side of the slide. You can see that, but this is a dot code, and also we have a volumetric. In a volumetric, we have a PV per volume that we can find it with the core lighting, and we have a lot of formula about this parameter that we can find the volume of the acid in a carbonate formations. But when we want to calculate the volume of the acid in a sandstone is easy, but in a carbonate is very difficult. Is difficult than the sandstone. We have three types of the acidizing: soaking agitation, fracture acidizing, and also a matrix acidizing. So in a soaking agitation, it means that the acid wash or wellbore clean out. Just we want to clean the wellbore of the well. In a fracture acidizing, in uh, uh, our injection rate will be above the fracture pressure. And in a matrix acidizing, our injection rate will be below the fracture pressure. Okay, for the acid wash, if you see the slides, you can see that when you have a calcium carbonate in as in a scale type, we can use the HCl acid to clean that, because it will be solved in acid. And we have this three type of the acid wash or soaking agitation. We can soak it in a short time. We can soak it in some minutes, and also we can pump it pressure apply against the perforation without exceeding the bottom hole fracture pressure. But one thing, sometimes when our acid volume is very low, maybe sometimes the clients ask us that please add some additive more depend on the laboratory dosage more to keep it in a well more time because maybe they cannot clean up the well or also maybe sometimes ask us to lose it in a well because the volume is very low. Because after that, when we want to do a matrix acidizing jobs with a big volume with a simulation vessel, the volume of the acid wash will be very low and very small. And what is the purpose for the removing a scale for the cleaning open perforations and also react with the formation phases. What is the fracture acidizing? Fracture acidizing, we inject our acid, um, in fracture acidizing, the acid injected through natural or induced fracture and pressure and usually exceeded the formation fracture pressure. If you see the picture, you see that fracture acid involves the injection, the acid injection, okay? But since the rock will not accept all the acid, pressure build up. We will see the graph. Pressure build up, and finally the rock ruptures and the acid injected down a fracture within the limestone formation or as in a dolomite formations is not different. Fracture acidizing is an alternative to hydraulic fracturing or prop fracturing. In a fracture acidizing, we do our jobs with the acid, but in a hydraulic fracturing, we inject a non-reactive fluid to create a fracture. And after that, we pump a prop to keep the fracture open. But in fracture acidizing, when we do acid jobs, and after that we pump acid into a well to etch the fracture, etch with the acid to provide the liner flow channels to the well bore. And low permeability carbonate formation are the best candidate for the fracture acidizings. Here, we have sample jobs of Halliburton. You can see that one stages for the main frag pad after the main frag acid, and you see that why? Because when you pump it the pad, you build up the pressure. After that, when you want that, you inject your acid. For fracture acidizing, first step is pad. Create a fractures. Size of a pad depends on upon how large a fracture is required. And step 2, acid dissolve the rock. Usually use the 15 to 25, but keep in your mind, I think that for the dolomite is better to use the 15%, and for limestone is better to use the 28% of the acid. But some other references tell us that 22% of the acid, HCl acid, is better than other. I don't know why, but keep in your mind, we can use it 22% also. And another one is the and for the overflush or for the displacement. But two major problems we have involved in acid fracturing. For the fracture closure after etching, we can combat fracture closure in uniform soluble carbonate. Hydraulic fracture and propping should be considered, as well as a special acidizing technique to design to provide the flow channels. You can use some prop also. And also another major problem is plugging the fracture if appreciable undissolved fines are released by the acid. So when we comfort with this problem, we should use some the silt suspending to suspending the silt or some element that plug the fractures. Here you see that in a fracture for the first stage, okay, our buildup, and again we reach to the perforations, again down, and again injection, again go again we test it to for formations and for perforations, again and again to find the best volume and the best rate for our fracture acidizing. In acid fracture, a pad fluid is injected into a formation at a rate higher than the reservoir matrix will accept. Here you can see that acid leak-off accelerated by wormholing. You see that the live acid go inside, and after that the spent acid will be a leak-off. And another we should know about that the fracture acid is applicable in a carbonate, but in a sandstone formation we should use a hydraulic fracturing and hydraulic fracturing. And just to enjoy here, some parameters are important for us about the etching the fractures. One is the rock properties and another for the type of acid, and also about the percentage of the acid is important for us as like as the type of acid, and another one the contact time is like as the organic or mineral acid. When you use a organic acid, you react slowly, okay, but maybe your penetration will be more or etching just for this face of the formations. Another one, contact time, the pumping rate and the total volume of acid pumped determine the contact time of live acid with the fracture features. Contact time has a direct bearing on the amount of etching obtained. But here, and some parameter is important for us about the fracture geometry. What? Injection rate, fluid viscosity, fluid volume injected, fluid loss, rock properties, formation fluid, formation stresses, and also the reaction rates. These are a parameter that the simulation engineer should be considered. So the client asks us that I want to fracture acidizing a well. Okay, which parameters do you need to do a fracture acidizing? First of all, formation thickness. If you see the middle of a slide, in the middle of in this slide, you can see that permeability, porosity, depth, fracture gradient, Poisson ratio, sonic travel time, temperature, reservoir. Why sonic traveling time? Because we can find about the Young modulus, bulk modulus, about the stresses. So with this parameter, you can find which direction of your fracture will go, or the half length of the fracture, or all parameter that important in a fracture acidizing. This slide is you can see that we have two type of the fracture acidizing: viscous fingering or pad acid, and another one the viscous acid fracturing. In a viscous fingering, because of the lower viscosity of the HCl, or HCl organic is pumped into the fracture, okay, this maybe make a phenomenon of fingering. You know, you can rate this file. You see that the viscous finger or pad acid method is one of which formation is first hydraulic for the first time hydraulic fractured. Okay, with the non-reactive as like as a hydraulic fracturing. And high viscous gel normally cross-link gel water. This is used to create a desired fracture geometry. Next, a lower viscosity acid will be pumped. The acid fingers through the higher viscosity pad. Because of this viscosity contrast and consistent mobile difference. But another one we have a viscous acid fracturing. Our viscous acid fracturing uses systems such as a gel, emulsified or foam acid or chemically retarded acid. These systems are used to both to create the fracture and differentially etch the fracture faces. You can see that in a viscous fingering or pad acid, what is the volume, how much volume we can use in our acid fracture. For example, for acid to 100 to 150, but these are just a scale, not a accurate one. What now? What is the matrix acidizing? Matrix acidizing is accomplished by injecting chemicals with the acid to dissolve or disperse materials near the wellbore. Near the wellbore that impair well production in sandstone and to create a new unimpaired flow channels between the wellbore in a carbonate. Keep in your mind, acidizing by itself can decrease the skin factor, in sandstone to zero, maximum to zero. But in a carbonate formation, uh, can be maximum to -5 or -6, I think. But in a sandstone formations, when we do a hydraulic fracturing, yes, we can change our skin factor also. We have two type of formation, yes, sandstone and a carbonate. Sandstone by itself has a good porosity and also good permeability, but carbonate we have a lower porosity, but because of the natural fracture, will we have a maybe better permeability. But typically, lower permeability limit for matrix production is about a 10 millidarcy for oil, well, and also 1 millidarcy for a gas well. But I think that for the condensate well, as well as the oil well, for the matrix is better for about the 10 to 20 millidarcy. In a matrix acidizing in sandstone, our aim or our goal to increase the formation permeability in the vicinity of the wellbore by dissolving some formation materials with a mixture of the HF and HCl acid or mud acid. And the purpose of the sandstone acidizing is stimulate the permeability of the formations. So in a sandstone formation, just we want to remove some plugging element or plugging silt in corresponding of the sand. We want to eliminate this plug, and just we want to again the well back to its production at first time in a better condition. And when you want to find the HCl and HF dosage, you should use a core flaw testing. And another parameter that's very important for us to find which dosage is better is temperature. Temperature has a marked effect on the reaction rate of the hydrofluoric acid with the sand and clay. If you see that here, common strength of the mixture of the HCl with HF, you can see that the 6 0.05, and also just keep in your mind about the regular and about the supermod acid, because in a normally or in generally we use that those two types. And again, in a matrix acidizing, in a sandstone, when we use a higher strength of HF, maybe we remove a lot of clays, and maybe can lead to large increase in flow improvement ratio. Whilst removal of silica coating, allowing the solution of the carbonate deposit, increases the formation solubility. The overall effect of these two actions is significantly increasing in reservoir productivity. Okay, here is everything's good. But when you use the highest strength of the HF, maybe you remove more and more, and after that, after acidizing, you comfort with the sand production. So you should consider about the strength of the HF acid in your acidizing, and also about your finding the value of the overflush that contain HCl acid. Another that it's very excitable for me is a matrix acidizing in carbonate, and my major and my special designing in the carbonate formations. Carbonate matrix acidizing is a well stimulation technique that where acid are injected less than formation pressure bypass the damage zone around the wellbore. Just keep a look at the picture in the left side of the slide. You can see that when we use a small volume as the acid wash or soaking agitation, just we do a phase dissolution. We do it more. We increase our HCl acid more. You can see that our conical channel will be occur, and if you see that limited penetrations, more volume, more penetrations, but think about the volume, think about the reaction time, think about which additive should be added to this acid to get the good result. In a matrix acidizing carbonate, okay, we can use some concentration or a strength of the acid 5% in a preflushes. My main opinion in carbonate formations acidizing in a preflush step, when you don't have any aquifer near the wellbore, okay, use acidic preflushes. I will talk in the last slide also. So we use a 5, 10, 15, and also 28% acidizing. When we use a 28%, when we bullheading the acid as in a simulation vessel, our rate will be about the 16 barrel per minute, and just you want the rate and fast reaction, you should use a more strength acid. And the acid volume ranges from the 10 to 200 gallon per foot, and also about the 500 GPF or gallon per foot in an extended matrix acidizing or EMA can be the result comparable with the hydraulic fracturing. Organic acids such as formic or acetic acid are used mainly in retarded acid system or in a high temperature application to acidize either in a sandstone and or carbonate. Again, these two can be as an additive and used in our acidizing. No difference in a carbonate or in a sandstone formations. Matrix acidizing carbonate, okay. When we want a deeper penetrations, when we want to provide the retardation, when we want to our acid compatible with the reservoir temperature, we use some retarded acid or some emulsified acid or gel acid to provide retardation again to achieve a deep penetrations. When we use a diverter, when we want to our acid compatible with the high temperature in a line interval well. So our emulsified acid, how we can make it? We can our acid emulsified with the hydrocarbon, normally with the diesel, and a gel acid with the gelling agent as a polymer or viscoelastic surfactant and other, and also we can use. Here you can see that the matrix acidizing, yes, some slides, I think I forget to write a reference here, but some slides take it, but I think that the references, I write it at the last slide. You can see that the pressure of the injection should be lower than the fracture pressure. So we have some type of the matrix treatment, wellbore clean out. You can see that the wellbore clean out wellbore, the volume ranges from the 10 to 1025, and another one NWS or near wellbore stimulations, the ranges from the 25 to 15 GPF. Let me tell you about the GPF, gallon per foot. You know, where our reservoir has a for example 100 foot interval. Okay, so what is the main acid volume? So 100 foot multiply to, for example, 50, about the 5,000 5,000 gallon. So this gallon per foot, it means that about the interval of the reservoir. Again, another one, the extended matrix acid that I told before, that we compare it with the hydraulic fracturing because of the more volume of the acid we should use, and the preparing of this this volume of the acid in a field is very very difficult. And because when you have a big interval, you cannot bring this volume of acid. Just maybe you can do a EMA acidizing jobs in a normal interval as maybe a 10 meter or maybe 5 meter in some old oil well. Let me see. Okay. Horizontal wall and well acidizing. All aspect that we use in a vertical well, for example, with a coil tubing or in a ball heading, we can use in a horizontal well. But when our horizontal well has a big interval, we should use some diverter to coverage the first stage that the acid go inside. After that, the diverter and the main acid repeated to cover all interval of the acid. In a horizontal well, we should use a diverter to acidizing. Here, I write a logo. It means that important just for the word for me. A ball heading acid into a horizontal well has generally proven to be unsuccessful. I write here, but I don't believe that. Because when you do it with them, when you do acid jobs with the biggest simulation vessel, you should ball heading, because the coil tubing cannot reach to depths of the bottom depths of the well. So another article study just I read for you. Horizontal weld acidizing indicate that the more horizontal length that is acidized, the more production is possible. Acidizing 25% of the horizontal length properly will provide approximately 75% of the productive potential if all the length has been acidized properly. This important result became a 75-25 rule. Okay, just now, before we start the diversion technique, please, if anybody has any questions, please write in a comment box and I will answer. If I know and my knowledge help me, I will answer. Just for 2 or 3 minutes. No question? Okay. No, 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 no. Yes, ask your.
Are you hearing me, sir? Can you hear me?
Yeah, I hear you.
Uh, Thank you. So I have some small questions.
Yeah,
For example, my first question, how can we choose between like in well stimulation? We have two methods of acidizing and fracturing hydraulic fracturing. How
yeah.
can we choose the better one for
Uh, you
our
know, if you listen to my voices, for the sandstone acidizing, okay, if you do acidize for a matrix acidizing, just you decrease the skin factor maximum to 0, okay? But in a carbonate, you can dissolve the carbonate and uh, increase the also permeability and also some porosity, okay? But here, when you have a small permeability in a sandstone, you can do and the best stimulation technique is the hydraulic fracturing in sandstone. Okay, but when you have a small millidarcy or low permeability in a carbonate formation, you can do a fracture acidizing carbonate. But in a both of them, in a sandstone or in a carbonate, when you have a normal permeability, you can do a matrix acidizing, I think.
So it depends of the permeability.
It depends of the permeability and also the cost of the operations.
Okay, thank you. And for the acid, there is a lot of types you show us in the presentation. There is
Yeah,
organic and the mineral. How can
yeah.
we choose the type of acid, like the better one for our well?
The acid is normally is HCl and the HF is better, uh, HCl for carbonate, organic acid, because of the low reaction rate, we use it as an additive. Again, I told before. For example, formic acid, you can use it as a corrosion inhibitor intensifier, and also the acetic acid, you can use it as an iron controller. We use all of them, but we use it just for the we use it next beside our main acid. Normally we use a mineral acid for the acidizings, but in a deep penetration, some references told us that you can use the acetic acid or an organic acid, but I think that the cost of operation will be more. Okay, Mohammed, if your question finish, let me another question I will answer, and after that we will continue, and at the last slide we will answer again. Okay, I'm here. If the
Okay, so thank you
Nikhil
so much.
Agarwal give us a permission, I can talk here more and more hours here.
Yeah, thank you so much, sir.
Yeah. Okay. Just Mohammed Aska. Yes, come.
Hello, Mr. Payman. Nice
Yeah. Hello.
presentation. Thank you for Hello, nice to meet you. I have two questions. The first one
Yeah.
is if you have some skills deposited inside the compilation, the tubing string and the casing, would
Yeah.
you perform the stimulation job with the formation and make the acid pass across these scales inside the compilation, or make
Yeah.
a tubing cleaning job first if you
Yeah.
made it in your career? First one. The second question is about using plating agent like EDTA and DTPA in stimulation. Did you perform this chemical solution inside the formation or just for acid, or just for scale dissolution and cleaning inside the
Uh,
compilation?
Mohammed John, could you please write your question in a comment box, because I have your voice I say stop by stop. Please write your question in a comment box. In the last slides, I try to answer your question if uh, you will be convinced about this one.
Okay, thank you.
You're welcome. Okay, I will continue in my slides. This is the diversion technique. We have two type of the diversion techniques, mechanical and also chemical. Mechanical, for example, mechanical and chemical. For the chemical, Ball-Sillars particulate diversion, foam acid diversion, and viscous fluid diversion. And what if you see here the last slides, in most cases, the acid has a tendency to enter the formation in a zone close to vertical section, those obtaining only partial assimilation overcome problem to use a diversion technique. So we go to next slide is here for the mechanical diversion technique. In a mechanical diversion technique, absolutely we should use a coil tubing. Yes, this is unforgettable saying that we should use. And another thing, we should use some straddle packer. A straddle packer, when we want to use a straddle packer, we should use some straddle packer in the way of interval, but it maybe has a more cost. But when you use a bridge plug, you can use a secured one zone and one by one, and after that you can use an acid. You can acidize the select. You can you can do a selective acidizing. Here just for some informations about the some coil tubing. I think that all know about the coil tubing. Some benefit of the coil tubing: protect well productions, avoid iron or other contaminant, enhance placement, apply jetting energy, use for the long interval, but I don't believe this one, because when the coil uh, wants to reach to line interval, maybe our buckling or our weight of the coil will be eliminated, and we cannot do this one. But some Disadvantages this for the rate limitation, yes, because we need a more rate, not for the not for example 0.5 to 2 barrel per minute maximum, and also inhibitor loading because of the coil tubing reel. We should use the more corrosion inhibitor, and and also about the operational cost and about the logistic, because when you in offshore, we should prepare a vessel to find the vessel. The weather is better. If the weather is okay, coil tubing, go to the next rigs, and the crane lift it up. Maybe it takes a lot of time. So here, if you see that, just for the more information, coil tubing has a power pack, has a control cabin, has a gooseneck, has an injector head, side door, slipper, lubricator, BOP. We should know about the BOP or quad BOP. In the next slide, I will tell you. And this in the left side, if you see that this is one chart procedure for the coil tubing acidizing that I've designed before. You see again here for the quad and BOP, you can see that the blind ramps, shear ramps, slip ramps, pipe ramps. If you accept that, I will talk more about coil tubing, and we will show more clip video in our workshop. This is my last job in with the coil tubing, that for the acidizing package, we have a nitrogen unit and with the tanks, and also acid carboy. And about the coil tubing, you see the rig of the coil tubing. You see that in the left side of the slide, you see that I wanted to find or calculate the volume of the coil and use this there, and I want to check that the flowing in a coil and the rig up, and also other sliders. And another diversion come to chemically, another diversion, a ball sealer. Ball sealer is a rubber coated ball that are designed to sit in the perforations. Reactive fluid carry the balls on a place on the perforation tunnel and high perm zone, like them, and divert acid to their interval. If you see that just ball sealer applied in a well completed with the perforation casing. So in an open hole, okay, forget about the ball sealer. And for my opinion, ball sealer nowadays is not a good diverter for us. Another one is as a ball sealer, a diversion techniques is a particulate, fine particles are added and placed against a higher perm zone. You know, ball sealer and also a particulate go and sit on a high perm zone or less damage zone, and create a relative low permeability filter cake on the formation, and after that the acid go to next a step. So if you see that some particle like chemical diverting agent as a benzonic acid flakes, water oil soluble salts, and also oil soluble resin. And another one is the complicated, I think complicated and excitable diversion, but we don't use a lot of, because in a marketing don't use this type of diversion in acidizing. For the foam acid, when we using a foam diverting technology, the first stage of acid solution is injected the formation as in a conventional acid. Okay, we inject the acid at the first, and followed by aqueous solution of a foam producing surfactant, which is displaced into the formation with a compressed gas such as a carbon dioxide or nitrogen that normally we use the nitrogen. Foam restricts the flow of reactive fluid to high perm layer and divert the fluid or acid to low perm layer. And a foaming and the acid reduce the effective amount of acid. So we should use the highest strength of the HCl acid, for example, 28%, when our foaming reducing the strength of the acid. Okay, it's not our a major concern or a major problem. So we choose a high strength acid in a foaming acidizing. Foam diversion, absolutely. Again, we should do it with the cold tubing, because we go with the cold tubing at the top of the perforation or at the top of the zone that we want to acidize. And after that, we inject the acid, again foam acid, and again step by step. Here, the advantage of the foam diversion techniques are over conventional diverting methods using solid blocks material or as follows. Foam produce a block within the formation, rather the solid block as a ball sealer or particulate. The compressed cask aids in cleaning silt and undissolved particles that it's have this sentence happy me in a foam acid diverting, because the compressed gas aids in cleaning silt and undissolved particles from the formation and in the cleanup fluid, and adaptability to wide range of temperature, 70 to 350 Fahrenheit. Here you can see that the chart of the photo of the foam diversion technique. You can see that the foam clean the work by displacing oil or condensate. Next one, saturate the near well former. Stage 3, foam bag is formed in both layers, and in a shutting period, foam dissipate rapidly in a damaged zone, and injected treated fluid containing former acid preferentially flows into a low perm layer. Okay, and now you see that the acid go to a low perm zone. An efficient diversion technique, fast and efficient in a cleanup. Again, fast and efficient in a cleanup. It is important for me because we don't have any shutting time in acidizing, but because of the some delayness in our jobs, we put some shutting time. Shutting time is very dangerous for the well, and the treatment design to suit condition and enable some flexibility to optimize the treatment. Here you can see that the foam, how you can see that in a field. This slide is, I take it, this photo, I take it from the one of the website field example of foam acid treatment, nitrogen foam in the field. You can see that a low permeability zone and observation zone, low permeability, and at last you can see that the acid or inject our fluid inject to our low permeability zone. Another type of the diversion we have, this is a VCA, viscosity control acid, one of the viscous fluid that we use in our diverting. A VCA is a polymer base. And when we inject it after acid and after VCA inject the acid, and we stop our pumping with the overflush pumping and displacement, when the around pH almost about the 4, with the some special powder, I think that the name is Furcheck, it will be break, and the cleanup procedure will be a start at the end of the acidizing. And you can see the in a laboratory, this is a if you see that the first photo is the live type of the VCA, and the second one is the spent with the calcium carbonate. The chemistry or lab specialist knows the name of this type of this type of the pouring of the spent VCA or also the VDA or VES, and we tell that about the coal tank. Another one, now in a marketing, we use it a lot of, and it has own price, and nowadays has a good answer to the specialists of the acidizing or stimulation is the VDA or VES. As the name is that the self-diverting polymer-free acidizing fluid can be used alone or with the treating acid to maximize zonal coverage. It is as like as the VCA, but the VCA is polymer based, but the VDA or VES is surfactant based. Okay, but the marketing, when compared with other diverting agent, they told us that they improve the zonal coverage. Okay, efficient wormholing behavior. Yes, because in a VCA, we use a 2 to 5% HCl acid to mix the polymer. But in a diverter, we can use a 10 to 20% acid. That this strength of the VDA can also penetrate in the formations and also cover the zone. Better leak of control. This is important for us as like as this is important for us absolutely in a fracture acidizing, and another high fluid efficiency during acid fracturing treatment, and simple mixing for a smaller equipment footprint. For the VCA viscosity control, you know, if you forget about the powder additive, maybe you damage to your zone. But here, when you want to break this type of the diverter, you should use a mutual solvent to break it as like as a liquid. You can see here live VES spent acid, and after that, when you reacted with the mutual solvent, you can see that as like as the water, as like as a fluid. And the next slide, it is my last job that in a water bottle, you can see that the live type of the VDA, and the next slide is spent, and another one when we reacted by our overflushes, the VDA break it, and you see that as like as the viscosity will be removed as like as a water. You can see that when you want to check your overflush and also your VDA in your job, you should check it together to see that your overflush performance is okay or your VDA performance is okay. Here for the LChem that show us that when we use a diverter, for example, VDA, what we achieve about the permeability, and also another when we use a viscoelastic surfactant treatment, what we achieve after acidizing. You can see that about the permeability here, and also the phase dissolution of the formations. Here, we have some formation damages caused by acidizing, as like a deconsolidation of rock matrix. In a sandstone, please please remember, I told before, when you use a higher strength of the HF, okay, maybe you release more element in your formation, and after that you consolidate the rock matrix, and also you maybe severe to sand production. Also another one, and a generating of migration or fine migration. You can see that another one, a secondary precipitation. It is one of the dangerous damage that after acidizing will be occurred, because in acidizing we should more care about the iron control additive, because precipitation of iron hydroxide can severely damage a well. There are two forms of the iron hydroxide that need to be considered: ferrous ferrous and also ferric. Ferrous hydroxide will precipitate it about out of the pH of 5 and or more, and whereas ferric hydroxide will precipitate out of the pH 2.2 or more. Therefore, ferric hydroxide is the main of the concern. With another one, water blocks. Water block is caused by an increase of water saturation and decrease the relative permeability. Another one, the fluid and additive incompatibility. Sometimes in a field you can see that maybe your acid in a live form, it's not acceptable. You can see, if not acceptable, please concerned about this one, and because maybe it damages your formations. And another one, for the wettability changes. For wettability changes occur when the rock that are normally wet with the water become with the oil. Instead, rock can be oil wet from the hydrocarbon deposit in the formation, or because of absorption of the olefinic surfactant from the treating fluid. In about the wettability changes, we should more care about choosing the surfactant. So, what is the acid additive? Okay, acid can cause a formation damage. Now we know about the formation damages that cause with the acid. So for that cause of the formation damage, we should use a special additive. We have some type of the additive as a corrosion inhibitor, surfactant, non-emulsifier, anti-sludge, iron controller, mutual solvent, friction reducer, clay stabilizer, divert, alcohol. Okay. Now go to next slide. If you see these are our additive from our company, but maybe the color for some marketing will be changed or different. Here for the surfactant, I told before, surfactant should be used for the all as to reduce surface and interfacial tension, to prevent emulsion and also to water with deformation. Corrosion inhibitor, why? Because the acid has a tendency to corrosion the pipe, and also the completion, or also we should use some dosage, best dosage of the corrosion inhibitor. For example, for high temperature, we use some intensifier as like a formic acid to assist to or aid the corrosion inhibitor. Anti-sludge agent, for example, some crudes, particularly heavy asphalting crudes from an unsuitable sludge when contacted with the acid. Because of this one, we use some anti-sludge agent and to cure this parameter. And another one, non-emulsifier. When our acid wants to be emulsifier, we use some non-emulsifier because we want to we want the reaction rate of the acid, and the non-emulsifier has a non-emulsifier is a temperature sensitive. Another important additive, iron controller, I told before, we can use acetic acid, but we have three type of the iron controller, pH control, such as acetic acid, sequestering agent as a citric acid in a powder. Citric acid normally in a marketing in a powder type, and also EDTA or NTA, a reducing agent, convert ferric to ferrous ion. And another for clay stabilizer, maybe we have a kaolinite, and also if we have a smectic or Montmore unit, we should use some clay stabilizer to control the water sensitive of Montmore unit. Another one is alcohol, or also a mutual solvent. We use it also for the water block, for the maintain water wet formations, to also increase the vapor pressure, but alcohol can cause to increase the corrosion. For the acid additive consideration, we should know we should consider some parameter as like as a compatibility. We should see that in a live is this okay or not? Compatibility with other additive. Maybe some company buy some additive from one company and some another additive from other company because we should because they should compatible together. Compatible additive with each other, the common problem encountered when the mixing of anionic additive with cationic additive. About the solubility, some additives are soluble in acid at a low concentration only, and at a high concentration, this additive will flocculate out. Maybe if you use a high concentration of the corrosion inhibitor, the corrosion inhibitor will flocculate at the at the top level of the acid. And also another dispersibility, if an oil-soluble additive is to be used, a dispersant must be added to the acid system. A good example of this dispersant is the xylene. So now matrix acidizing candidate selection. Matrix acidizing candidate selection, we should know at first about the production and also the economic return, about the review numbers well, about the well-like record reservoir characteristics, productivity of each well. If we do acid job, the economic or the money come back again or not. If no, okay, leave it. And do a low cost stimulation jobs, establish reasonable, evaluate potential mechanical problems, and check the formation damages, focus on well with the highest reward and lower risk. Now we want to start the how we can do or made a matrix acidizing jobs. For the matrix acidizing job, we should know about the formation properties, deviation, oil or gas well, or old or new well, open hole or case hole, about the completion, about the perforation interval, and also about the net or gross interval, and also about the reservoir. Here, here, for the first step, this is a data, this is a table that I ask from my client to find the and calculate the matrix acidizing and design a matrix acidizing. Here you can see the formation type, reservoir temperature, for reservoir temperature. This table you should have for yourself, because maybe some type of parameter here that help you in designing the matrix acid jobs. Here another one, after you take your data, okay, you should find your best solution, your best acid. For example, you know that the formation is carbonate. Now you should find the HCl acid, which strength. Okay, we have a pump, ESP pump in a well. Okay, we don't use a higher strength of HCl in acidizing. We use maybe 5 to 10% HCl acid. We use acid with the cable that connected with the ESP pump, because we should maybe the acid corrosion this table. And here you can see that some laboratory jobs that we do a compatibilities, corrosion test, iron control test, emulsion test, and diverting performance. I think that every parameter I told before, but again, with the core flooding, you can see that we can find the HFHCl, and also about the rate injection, and also about the permeability. We can find the permeability better and other things. But for the compatibility test, we go to next slide and find. In a compatibility test, we prepare the acid with the recipe that the laboratory give us, okay? And we put it in a temperature of the well. Okay, for example, in a water bath, we made a temperature about the, for example, for this condensate well, we made a 194 Fahrenheit, okay, and we check that after 6 hours is okay or not. Again, another for the emulsion test, prepare a main acid, or also we can divert, but in an emulsion test, our measure is the main acid. We check it with the fluid of the well, and we check that after some minutes separate together or no, or make a knife edge or no. Another one for the divertor performance, you can see that we need to check the divertor performance. You see, we should find the coton, or also we can check it in the our HPHT viscometer and check that the viscosity and also the strength of the diverter. And then one of the important, if you can see the right side of this slide, the iron control, you can see that the acid, when we react with the element that has an iron, you can see that if the iron control doesn't exist in our procedure, we'll make the right side of this sample. But if we use the iron control, we can suspending in our acid. How we can do an iron control test? We prepare a main acid solution as a per recipe, or our laboratory give us, add Fe chloride 3 by amount of this gram to 10 milli of solution to get 1000 ppm iron solution. Add 8 grams NaOH solid in a 100 milli water to make 2 NaOH solutions. And after that, we neutralize iron solution by adding 2 NaOH solution till to pH to reaches to 5, because the precipitation of the iron will be at a 5 pH 5. And another step for the matrix acidizing is to find the acid stoichiometry reaction about the gravimetric and volumetric to find the volumetric dissolving power. If you see that the right side of the slide, I have my own Excel file that whenever in a field I confront with some formula, I use it and create an Excel for myself. Because when you create this Excel for yourself, you can change some parameter in your list, and you can see that which parameter is more important than other parameter. For example, in my Excel file, that I found that when when you wants to check or calculate the rate of penetration or maximum injection rate, if you change the thickness of the formation, your effect of inner rate of injection will be more. So if you do or make an Excel file for yourself with some formula that comfort in a field, it's better to understanding the comprehensive of the acidizing or anything that you want to learn. Step 4, we want to calculate the pumping pressure calculation, because we should know about the fracture gradient of the field, because in a matrix acidizing, we should consider about the fracture pressure, and our pumping injection should be below the fracture gradient. How we can find it with this formula, but absolutely, and If you want to learn more, I will do more sample about the formula in my workshop, and you can find it more and more. And the next step is the how can find the pumping rate calculation. These are the more formula, and pumping rate calculation. I told you can see the skin, you can see the you can see the permeability, average permeability, you can see the thickness, and after that you find the injection. You should gather all data together in a normal way, and in a normal step we use a preflush at the first step. We use a main acid with a diverter step by step to acidizing. After this one, we use the overflush, and after that, at the last one, we use a displacement water. Okay, so now we find all data. We gather it together, and now we want to find our plan is okay or not. For now, there's some simulation software in a marketing is very much as like as a Steam Pro, Frag Pro, Wellbook, and Matrix in a newly for the Schellenberger. I think you simulation you're designing. You see that, okay, now my skin is okay, now my pressure is okay. I think that the pressure is okay, my pumping rate is okay. My opinion again, no simulation software are reliable now because every simulation software has on its policy as in its formula. And I think that if you fill your field data in three type of the software, absolutely, I promise to you, you can not take same result. I promise. Go to next slide. So here, now I want to tell about the preflush. What is the preflush? The preflush allows the formation to react with the acid in the oil producing interval whilst restricting the invasion of acid into water producing strata. But one thing, sometimes we want to acidize with the coil tubing. When we want to do a coil tubing, one stage is the pickling for the coil tubing. We use some acid with the corrosion inhibitor to pickling the coil tubing, or pickling the tubing, or pickling the formations. But sometimes we use and sometimes we don't use. In sandstone formation, it is very important to use a preflush, and in a preflush normally with a 5 to 15% HCl commonly we use. And the preflush serves two purposes. It dissolves carbonate in the formation so that the following hydrofluoric acid will remain active to dissolve the clay and silicates. It removes calcium compound, minimizing the formation, compound soluble precipitation. Another preflushes we use, we can use for example, aromatic solvent and diesel. We can use mutual solvent and alcohol. We can use hydrochloric acid. But my opinion, if we want to use acid just for example in a carbonate formations, okay, acidic formation, I told before, if we don't have a aquifer zone in near our wellbore, we can use more dosage of mutual solvent and also alcohol with them. And also if we want in an oil well, when we want to get a good result and better cleanup operation, we should it's better to use a diesel at the first stage for the pre-flush. And now and also for the water wetting formation rocks, here you can see the 6 type of the pre-flushes. Here we go to about the overflush at the last stage before the displacement. Overflush is displacement of the acid treating solution with a more than the volume of the required to clear the tubing and the casing. When using retarded acid system, the reaction time can be longer than the injection time. For example, again, for the oil well, it's better to use a diesel, or also for the carbonate, don't use again acid, because it's better to use just mutual solvent when you use a diverter, because you want to break a diverter in your formations. For the dry gas well, you can use the acid with the alcohol, but again, I think that the acid is not okay. The alcohol and mutual solvent can help us, and also the diesel, because you can lift it more easiest than other fluid that you want to inject in the well. And another one, the overflush can help us in a clean up the well, Good choosing in overflush type of an additive help us in clean up the well. So successful matrix acidizing jobs when happen when our acid jobs, okay, we do perfect, but when you clean up the well perfect with the professional completion or production engineer consultant, or with a chokeman, because they should know about when they should open the choke or open the well to clean up the well. Don't clean up the well, don't open the choke as maybe for the gas well around the 72 at first. No, it's not okay, because at first we want to clean up the acid from the well. After that, the acid comes out, our well be live and should be clean up well and well. And another shut-in time. What is the shut-in time? The length of time well is closed in after a stimulation treatment is completed. I told in a carbonate formations, or also in a sandstone, we don't have any shut-in time, meaning because just we control it with some additive and it has a more cost. But when, for example, the vessel approach to platform and wants to depart it from the platform, it takes a time. We should take a time from client or NSS. So now we put a shut-in time with some additive, and now we departed from the platform. Here, the acid flow back cleanup, the purpose of backflow after acid job is remove the liquid gases, solid and emulsion from the well. What is our product after acidizing? For example, for carbonate, calcium chloride, calcium CO2, H2S, emulsion, and also foam spent acid with some oil foams, solids, as like a calcium chloride. Here you can see that, remember that the main liquid flowback from an acid job is calcium chloride brine. With the higher density and more emulsification problems, denser fluid are more difficult to lift and may precipitate scale and minerals as the iron, ferric, and ferrous are typically seen in production operation. Recover spent acid fluid as quickly as possible to minimize the problem. So shut-in time, it's better no have. Acidizing job evaluation, we can evaluate the acidizing job during the job, but after acid jobs we can see better, because in a VDA type of the, or when you use some diverter in a pumping system, when you monitor your data, you cannot find the performance your diverter, or maybe if it is a passive, if the diverter is polymer based, you can see the effect of your polymer polymer, when it is a surfactant or and with the high percent of acid, HCl acid, you cannot find the best performance of your VDA just in a monitoring. So after acidizing, you can compare it with the before pre-acidizing and after acidizing. You can compare it with the pressure and also with the BSNW, because these two parameters as the pressure and BSNW are important for the clean of the well after acidizing, and also they find the best choke. And when the acidizing job does not work, okay, we don't use a good volume for acidizing. We don't use we use a bad additive, expire additive. We don't clean the acid as soon as possible. Inadequate volume of mud acid. We use a dirty water in our overflush or our also in our preflush, and uh, and other I think, but I think that is normal. But this is our simulation vessel. What is this procedure? This is as other we engineering plan design. We load acid in our port, our safety meeting, we our rig up pressure test as a normal. We pumping as a schedule of program that engineer give it to us. We after acidizing job clean up the well, secure the well, clean up operations, and the secure. We can use. You can see that a normal rig up to a wellhead from the vessel. You can find that the 2 flow meter, 2 pressure sensors, and also with the whole co-flex tip. And we rig up with the 3-inch or 4-inch, but here we rig up for with the 3-inch line. And another, this is our treatment schedule. You can see that our job plan, for example, you can see that our acid just for the first stage is pre-flush, non-acidic. Here mistake as in a non-acidic, acidic HCl, and none is eliminated, should be eliminated. And main acid step by step and change it, and again and again. And you can see that the graph that we monitor during the well. This is the place of the we placing the additive on our meson deck, are approaching to a platform. This is the rig of fitted 2-inch just for the minimum rate. This is our CCR room and the chokeman, and also the our cleanup operation. And now just I want to something about the geothermal well acidizing. In a geothermal well acidizing, I think that the time is over, and just I want to tell in geothermal acidizing, I will go to next slides, and you can take this slides, or you want to take a photo just then. After that, I will go to next slides. For the geothermal well acidizing, we use just HCl and HF, and also with some additive as like a corrosion inhibitor or corrosion intensifier, depend on the temperature. And the water wetting surfactant, no use, because we don't have any hydrocarbon here. And also we don't use any suspending agent and non-emulsifier surfactant. You can see that just we use in acidizing for the geothermal corrosion inhibitor and high temperature iron control we can use. And this is the sliders that a new technology that I want to tell you just for 1 or 2 minutes. We have more, but as like a slick frag or something like this. But here for too excitable for me, one of the EHS tools that electrohydraulic stimulation enhancing matrix acidizing, and more unique and newer technology for improving flow due to damage in the near wellbore area is with the form of the high pulse power called electrohydraulic stimulations, or EHS tools. Another one is the STEAM 6 that a newly born, I think, and the again the next generation of the matrix acidizing. You can see that in the next slide that I will new stimulation technology. We can use an acid HCl and HCl-HF or mod acid is generated via a exothermic reaction, which is initiated via electrical signal. Tool is made of a 4-component ball nose, dispersion tube, chemical carrier, and firing head. We can send it in a well with a slick line or with a coil tubing, and this has some advantage and ability to target acid to a specific interval, different acid for different zone, and no exposure to live acid at the surface, minimizes HSE risk. And Nikhil, I think that maybe I don't know. I want to Fraser Smith, if you are here and finished, my webinar is finished, and I'm happy that you attend my webinar, and I hope that you learn even a little and increase your knowledge even a little in acidizing and assimilation. Now I'm ready